Welcome to this hands-on project using Arduino. In this video, we will look at all the components required to build our multi-sensor switchboard. So first of all, we will take the Arduino Uno as our controller. Then of course, we will take the small breadboard. Now we will take one LED to show the sensor's output. Then we will take 3 photoresistors. Now we will take resistor and we will make the copies of it to set the different resistance. It will help us in current control. Then we will add 3 push buttons. 3 push buttons will help us to individually activate each sensors. So we will name differently to each photo resistance with flame sensor, IR sensor and LDR sensor. Now we will have to set the resistance to 10 kilo ohm to each resistor and 220 ohm to last resistor. Okay. So now we will check the configuration, component list. So these are the components required. Here is how we align our component on the breadboard for better organization. So we have placed the 3 sensors on the left side, each vertically with the pull down resistor. The 3 push buttons are placed in the row at the center of the board for easy access. The LED is placed on the right side with current limiting resistor, and all the components are oriented such that their connection are neat and systematic. Now that the layout is set, let's begin the connecting the sensor to Arduino. Let's wire up the sensors to the Arduino. So first of all, we will connect the minus of the breadboard to the ground of Arduino. Then we will connect the plus of breadboard to the 5 volt of Arduino. The LDR, IR and flame sensors output are connected to the analog pins A2, A1 and A0 respectively. Each sensor's other terminals go to 5 volt and a 10 kilo ohm resistor connects the signal line to ground. This creates a voltage divider, and we will use the green, blue and purple wires to distinguish the sensor lines. This setup allows Arduino to read different light levels or heat using analog signals. And in the next step, we will wire the buttons and LEDs. So let me color it to the green, and as I said, we will connect it to the A2, A1 and A0 respectively. So yes, and here is how our structure will look like. Now we will wire control button and the LED. Each push button is connected to digital pin 4, 3 and 2 and grounded using a 10 kilo ohm pull down resistor. This setup ensures the pin reads low when the button is not pressed and high when it is. Our LED's anode is connected to pin 13 via a resistor and the cathode goes to ground. All the connection go to their respective pins on the Arduino Uno. So let me connect all the components with each other as I said. And with this, our final circuit is ready. So let's check out how it will work. So now let's understand how our Arduino program works, first in a block and then in the text. Using the block editor, we read each sensor's analog value only when its button is pressed. So first of all, we will take on start, then we will set the flame sensors to signal analog pin A0, then same for the IR sensor and button LDR, and we will set the pin respectively A0, A1 and A2. and this option will be shown to you when you will create the variable flame sensor, IR sensor and button LDR. Then we will add the weight for serial input, so it will have the by default weight of 9600 milliseconds. Then we will add the loop of 100 time rotation. Then we will add the if condition, and when this condition will be true, then we will set the flame button to the 1, which will be in the variable section. Then we will set the sensor value, which will be taken from the pin A0. Then we will print that frame is pushed, frame sensor is pushed, and we have to actually repeat this process for the all the sensors for multiple conditions. Okay, so then we have this structure. So by default we will use the pin 13, and if the sensor value drops below a certain threshold, then the LED is turned on, and this logic is repeated for all the 3 sensors. So we will connect it to the our circuit, and this will how our block design will look like. And then we have the text code. So in the text code version, the same idea is implemented using the if else block and digital read and analog read functions. This flexible setup allows the LED to react based on the active sensor's input. So this is our threshold, and these are the functions. So it will how our program, text program will look like. So here is the complete simulation process of our multi-sensor switchboard. So first of all we will start the simulation. When you press a button, its corresponding sensor gets activated. Like we can see that we have pressed the LDR, the LED is starting, and the sensor is also taking the input and showing the output. For example, pressing a flame button allows the flame sensors to control the LED. If the fire is detected, the analog value drops, the LED turns on. Same goes for the IR and LDR sensors. This setup is great for understanding how multiple analog sensors can be toggled selectively using the buttons, making our project modular and interactive. Thanks for watching, and happy tinkering with Arduino. This will how it all works. Thank you so much.